The electric car revolution isn't just about batteries. It's about rethinking the very core of what makes a car move: copper. For decades, copper has been the unsung hero inside our vehicles, quietly conducting electricity and powering everything from the starter motor to the latest high-performance EVs. But as the world races toward cleaner, more efficient transportation, engineers are asking a bold question: is copper still the best we can do? For over a century, copper coils have been at the heart of our cars' engines and motors, prized for their conductivity and reliability. Yet copper is heavy, expensive, and its supply is increasingly uncertain as demand for electric vehicles skyrockets. What if we could replace these copper coils with something not only lighter, but also more efficient and sustainable? Enter carbon nanotubes, ultra-strong, feather-light threads of pure carbon, engineered at the atomic level. These remarkable materials are not just lighter than copper, they can also conduct electricity with astonishing efficiency, opening up new possibilities for electric motor design. As of October 2025, a breakthrough from South Korea has delivered a working electric motor with zero metal coils. Instead, it uses carbon nanotube windings, marking a world first in automotive engineering. This innovation could be the tipping point that changes how we build electric cars forever. This isn't a minor tweak, it's a fundamental shift in engineering. Swapping out copper for carbon nanotubes means reimagining the entire electric motor from the ground up, with the potential to revolutionize performance, efficiency, and even the way cars are manufactured. Imagine electric motors that are not only lighter and more efficient, but also run cooler and last longer. The result? Cars that accelerate faster, handle better, and offer a smoother, more enjoyable ride, whether you're behind the wheel of a sports car or a family sedan. By swapping dense copper for carbon, we could dramatically reduce motor weight, making EVs more agile and responsive. Lighter motors also mean more room for batteries or passengers, and potentially lower costs as carbon nanotube production scales up. This leap could transform not just supercars, but everyday vehicles, and even flying taxis. The same technology could power delivery drones, electric buses, and the next generation of urban mobility, making transportation cleaner and more accessible for everyone. We're diving into how this technology works, its potential to reshape the auto industry, and the challenges that still stand in the way, like scaling up production and ensuring long-term durability. Plus, we'll see how global politics, like China's control over key materials and the race for supply chain security, are pushing automakers to innovate faster than ever before, searching for alternatives that are both sustainable and geopolitically stable. This is more than a story about science. It's about the relentless drive to build the perfect machine. It's about creativity, competition, and the quest to solve some of the biggest challenges facing the automotive world today. The age of the coil-free motor has begun, and the race to perfect it is just getting started. The next few years could redefine what we expect from our cars. Let's see what the future holds, and how the materials inside your next car could change the world. To grasp why ditching copper matters, you need to know its legacy. Electric motors, from blenders to bullet trains, have relied on copper coils for nearly 200 years. Copper's conductivity and affordability made it the go-to material. But copper is heavy. A typical EV motor can weigh 150 pounds, much of it copper. That weight drags down performance and efficiency. Engineers have tried lighter casings and new designs, but the copper core remained. The dream? A motor without metal coils. Long thought impossible. The challenge: finding a material as light as it is conductive. Many tried and failed, but a new approach using nanotechnology is changing the game. Let's see how. The miracle material at the heart of this innovation? Carbon nanotubes, or CNTs. These tiny cylinders of carbon atoms are revolutionizing the way we think about building machines, especially electric motors. Their unique structure gives them properties that are almost unimaginable with traditional materials. These are microscopic tubes of carbon, each one thousands of times thinner than a human hair, yet stronger than steel and incredibly light. CNTs are not just tough, they're also flexible, and can conduct electricity with remarkable efficiency, making them perfect for next-generation technology. The breakthrough came from Korea's KIST, the Korean Institute of Science and Technology, where a dedicated team of scientists spent years perfecting a way to align and purify CNTs for maximum conductivity. Their work opened the door to using CNTs in ways never before possible. Their process, called LAST, or long-aligned spinning technology, lines up nanotubes like logs in a river, creating a clear, straight path for electricity to flow. This alignment is crucial because it allows the CNTs to work together, amplifying their natural conductivity. But alignment wasn't enough. The team also developed a special chemical rinse to remove any lingering metal impurities from the nanotubes, boosting their performance even further. This step ensures the cables are as pure and efficient as possible. The result? Ultra-pure, highly conductive CNT cables that are lighter, stronger, and more efficient than anything made with metal. These cables are a game-changer for electric motors and beyond. With these advanced CNT cables, the team built the world's first electric motor with no metal windings at all. This is a huge leap forward, showing that motors can be made entirely from carbon-based materials. The finished motor looks and works just like a traditional one, but it's built from the future. Its performance rivals and in some ways surpasses conventional designs, all while being lighter and potentially more durable. This is the first real step toward a new era of electric propulsion. With this foundation set, the possibilities for cleaner, lighter, and more efficient electric vehicles are closer than ever before. The KISS team's CNT motor is dramatically lighter, just 1/5 the weight of copper. This breakthrough in material science means that, for the first time, we're seeing motors that could fundamentally change how electric vehicles are designed and built. Imagine the possibilities when such a significant portion of a motor's weight is suddenly gone. In a standard EV motor, that could mean a 25% weight reduction. That's not just a small improvement. It's a game changer for automakers looking to squeeze out every bit of efficiency and performance. Lighter motors mean better range, sharper handling, and more responsive driving. With less mass to move, electric vehicles can accelerate faster, stop more quickly, and use less energy overall. It's a win-win for both drivers and manufacturers. The potential extends beyond cars. Think electric aircraft and drones where every gram counts. In aviation, weight is everything. Lighter motors could enable longer flights, higher payloads, and entirely new designs for electric planes and unmanned aerial vehicles. In tests, the CNT motor powered a model car and drone propeller, spinning up to 3,420 RPM on low voltage. These early demonstrations show that the technology isn't just theoretical, it's already working in real-world prototypes, even if on a small scale for now. While that's slower than copper's 18,000 plus RPM, the CNT motor's performance per weight is only 6% less. That's a remarkable achievement, considering the dramatic reduction in mass. It suggests that with further development, CNT motors could close the gap even more. It's not ready for hypercars yet, but the proof of concept is strong. The technology is still in its early days, but the foundation is there for future high-performance applications. Dr. Dae-Yoon Kim, the lead researcher, says they've maximized CNT coil performance to drive motors without metal. This is a major step forward, as it opens the door to motors that are not only lighter, but also potentially more durable and resistant to corrosion. The trade-off: less raw power for now, but a huge leap in efficiency and weight savings. The future looks promising. As the technology matures, we could see even greater gains in both power and efficiency, making CNT motors a real contender in the race for better electric propulsion. The next challenge: scaling up. Moving from lab prototypes to mass production is never easy. But if the hurdles can be overcome, CNT motors could reshape the future of electric vehicles and beyond. Let's talk hurdles. Exciting as it is, CNT motors face big challenges. Conductivity is the main hurdle. CNTs are still far less conductive than copper. That limits power and torque, restricting use to low-power, weight-sensitive devices for now. Manufacturing CNTs is also extremely expensive, hundreds of dollars per kilogram versus copper's 10-11. No automaker will pay 40 times more for a lighter motor. Scaling up production from lab to factory is another massive task. The current motors are tiny. Building full-size, high-power versions is a different ballgame. Durability and reliability under real-world conditions remain unproven. The road from prototype to production is long. but the potential is too big to ignore. Electric vehicles promise a cleaner future, but CNT production isn't green, yet. Making CNTs uses lots of energy, often from fossil fuels, and involves toxic chemicals like chlorosulfonic acid. The carbon footprint is high, and chemical waste is a real concern. Scaling up means managing these environmental risks. Cleaner, more efficient production methods are in development, but we're not there yet. The lesson: true sustainability means cleaning up the entire supply chain. The promise is real, but so are the challenges. We must ensure the journey is as clean as the destination. While Korea reinvents coils, India is tackling another motor problem: magnets. Most EV motors use rare earth magnets, and China controls 90% of the supply. When China curbed exports in 2025, India accelerated efforts to build magnet-free motors. Sterling G-Take e-Mobility is testing a British-designed magnet-free motor, aiming for production within a year. Bangalore's Chara Technologies has developed its own magnet-free designs, trading a small weight penalty for supply chain independence. Some companies, like Conifer, use ferrite magnets, cheaper and more abundant. India's largest magnet importer, Sona Comstar, is diversifying with new designs and local production. The industry is adapting fast, driven by geopolitics and necessity. Innovation is happening on multiple fronts. The race for resilient, homegrown EV tech is on. Breakthroughs make headlines, but scientists urge caution. Dr. Dae-Yoon Kim is proud of the CNT motor, but experts say it's just the first lap. The main issue: CNTs need much higher conductivity to compete with copper in real cars. Analysts predict 5 to 10 more years of research before commercial viability. The big three challenges: boost conductivity, cut costs, and scale up production. Early applications will likely be in aerospace and drones, where weight matters most. Success there could fund further development for cars. It's a familiar path for new tech: start small, scale up. The journey is long, but the outlook is hopeful. The revolution has begun. We're at the dawn of a new era for electric cars. For the first time, there's a real alternative to heavy copper coils. Carbon nanotube motors promise lighter, more agile, and more efficient vehicles. The hurdles, conductivity, cost, and environmental impact, are real, but solvable. Meanwhile, the push for magnet-free motors is reshaping the industry worldwide. The next generation of EVs could be lighter, faster, and built from local materials. Human ingenuity is driving this revolution. The future of electric motoring is just down the road.